Homework 7, Combinations of Functions, video number 1. In this section, we're going to learn about combining two functions to make a new function. But before we do that, we need to discuss domain. Now, I know we've talked about domain before. Domain is x's, range is y's. And when we talk about a function, the value that goes in is an element of the domain, it's an x, and the value that comes out of the function is an element of the range, it's a y value. But when you're talking about the domain of a function, as opposed to just domain in general, it has a little bit more specific definition. If you have a function f of x, the domain of that function is the set of all real numbers for x that make f of x both defined and real. It's these two words that we're going to focus on. Values that make a function both defined and real. Well, that raises the natural questions. When could f of x be undefined? And when could f of x be not real? There's a few things in math that remain undefined because there's no way to define them. One thing that always remains undefined is division by zero. So when could a function be undefined? When it results in division by zero. So for example, let's consider the function f of x equals 7 over x minus 4. What value of x would make this function undefined? In other words, what value of x could we put into this function but not finish completing it to get an answer? Well, since we have a fraction, also known as a division problem, the only time this will be undefined is when we end up dividing by 0. So what value could we substitute for the x in the denominator that would result in a denominator of 0? The answer is 4. If we try to put 4 into the function by replacing each x with a 4, we end up getting 7 over 0, and that's undefined. So that's an example of a value that makes a function undefined. And specifically, for this particular function, 4 would not be in its domain because that makes the function undefined. In fact, it's the only value that makes this function undefined. So 4 would be the only number not in the domain, which means the domain of this function would be everything except 4. We'll see how to write that in the next video. But when can a function be not real? And what do we mean by not real? Well, the very first thing we did in this class was discuss imaginary numbers and complex numbers. And you may recall that those arise when you attempt to take the square root of a negative number. There are actually other things that can happen to make complex numbers arise, but that's the only one that we're going to focus on. So the answer to when could f of x be not real is when it results in square rooting a negative number. So let's take a look at another example. We'll call this function g of x. Why? Why not? G of x equals the square root of x minus 2. Can you think of a number that when we substitute into the function would cause us to take the square root of a negative number? I'll give you a hint. There are a lot of numbers that will do that. Could you think of one? In fact, let's try the number 1. If we substitute 1 into the function, we'll take the square root of 1 minus 2. Well, 1 minus 2 is negative 1, and the square root of negative 1 is imaginary. And more importantly, not real. So what that means in the context of this problem is 1 is not in the domain of g of x. And I guess for completion, I should go back to the previous example and clearly state that 4 is not in the domain of f of x. In the first function, 4 was the only number that will be excluded, but can you think of other numbers for the second function that would be excluded from the domain? Would we exclude 3? No. 3 minus 2 is 1, that's not negative, so I can square root it, okay. Would we exclude 2? Well, 2 minus 2 is 0, and the square root of 0 is 0. But if you think about it, any number less than 2 will become negative when we subtract 2 from it. So we kind of see that there's a lot of numbers that would not belong to the domain of this second function, namely any number less than 2. But in the next video, we'll talk about domain issues and how to find domains for different types of functions.